Greetings, science fans. Bill Nye here. Today we're embarking on an extraordinary journey to two of our closest planetary neighbors, Venus and Mars. They're often called Earth's sister planets, but as we'll see, they couldn't be more different, especially when you look at their atmospheres. Think of it like this. One is a pressure cooker, and the other is a near vacuum. We're going to put them head to head, comparing everything from the air pressure on their surfaces to the wild weather patterns that sweep across their landscapes. It's a cosmic showdown of atmospheres. This isn't just a simple comparison for fun, although science is always fun. Understanding these differences is crucial for our future in space. The atmospheres of Venus and Mars dictate everything about them. Their temperatures, their potential for water, and ultimately, their habitability. Why is one a scorching, toxic inferno, while the other is a frigid, dusty desert? The answers are written in the air, or lack thereof. By exploring these key distinctions, we can better understand how planets evolve and what it takes for life to get a foothold. So buckle up, we're about to dive deep into the science of planetary atmospheres. We'll explore crushing pressures, runaway greenhouse effects, planet-engulfing dust storms, and the tantalizing search for water. By the end of this, you'll see why one of these worlds is a top target for future human exploration, while the other remains one of the most hostile environments in our solar system. It's Venus versus Mars, and the story is all about the air up there. Let's get started. Let's start with something you feel every day but probably don't think about: atmospheric pressure. Here on Earth, the weight of the air above us is about 14.7 pounds per square inch at sea level. It's just right. Now let's go to Venus. The atmosphere there is so incredibly thick and heavy that the pressure on the surface is over 90 times that of Earth's. Imagine being nearly a kilometer, or about 3,000 feet, deep in the ocean. That's the kind of crushing force we're talking about. The air itself is a dense soup, mostly carbon dioxide, so dense that it behaves almost like a fluid. It's a truly extreme environment, all because of that massive heavy blanket of gas. Now let's rocket over to Mars. If Venus is the deep end of the pool, Mars is like standing on the highest mountain peak, only much, much higher. The Martian atmosphere is incredibly thin, less than 1% of Earth's atmospheric density. The pressure is so low that if you were standing on the surface, the water in your body would literally boil away at body temperature. It's a near vacuum. This thin air can't hold on to heat, and it offers almost no protection from the sun's radiation. It's a stark, dramatic contrast to the suffocating thickness of Venus's atmosphere. So what does this all mean? These radical differences in pressure and density create two completely different worlds. On Venus, the dense atmosphere traps heat and creates a surface that could melt lead. On Mars, the thin atmosphere allows heat to escape, leading to a cold, barren desert. One is a heavyweight champion of pressure, the other is a featherweight. This fundamental difference is the starting point for understanding everything else about these two fascinating, yet wildly divergent planets. It's a powerful lesson in just how varied planetary evolution can be. When it comes to temperature, Venus and Mars are on opposite ends of the spectrum. Let's start with the hottest planet in our solar system, Venus. It's not the closest to the Sun, that's Mercury. But its thick, carbon dioxide-rich atmosphere creates an extreme runaway greenhouse effect. Sunlight gets in, heats the surface, but the heat can't get out. It's trapped. The result is a surface temperature that averages a staggering 465 degrees Celsius, or about 870 degrees Fahrenheit. That's hot enough to melt lead, and it's not just hot in some places, it's that hot everywhere, all the time, from the equator to the poles, day and night. Now let's contrast that with Mars, the red planet. Its thin atmosphere, which we just talked about, can't hold on to heat. So while it's farther from the sun, the main reason it's so cold is its lack of an effective atmospheric blanket. During the day at the equator, temperatures might get up to a balmy 20 degrees Celsius or 70 degrees Fahrenheit. Sounds nice, right? But at night, that same spot can plummet to minus 73 Celsius or minus 100 Fahrenheit. That's a massive temperature swing. And if you go to the poles, it gets even colder, dropping to minus 125 Celsius or minus 195 Fahrenheit. So we have one planet that is uniformly, relentlessly hot, and another that is generally frigid with wild temperature fluctuations. This is all a direct consequence of their atmospheres. Venus's thick CO2 blanket is an incredibly efficient insulator, turning the planet into a planetary oven. Mars's thin air is like having no blanket at all. leaving it exposed to the cold of space. These thermal conditions are a huge factor in why one planet is so inhospitable, and why the other, while still extreme, presents challenges we are learning to overcome with our robotic explorers. Water is the key ingredient for life as we know it, and the story of water on Venus and Mars is a tale of what is and what might have been. On Venus today, there's virtually no water to be found. Its atmosphere contains only trace amounts of water vapor. Scientists believe that Venus may have once had vast oceans, similar to early Earth. But as the sun grew brighter and the planet's greenhouse effect spiraled out of control, the oceans boiled away. The intense ultraviolet radiation from the sun then split the water vapor molecules in the upper atmosphere into hydrogen and oxygen. The light hydrogen escaped into space and the oxygen reacted with rocks. Venus lost its water forever. Mars, on the other hand, is a completely different story. While its surface is now a dry, frozen desert, the evidence of a watery past is everywhere. We see vast, dried-up riverbeds, deltas where rivers once flowed into massive lakes, and canyons carved by epic floods. Our rovers have driven over ancient lake beds and analyzed rocks that could only have formed in water. We know Mars once had a thicker atmosphere and was warm enough for liquid water to flow freely on its surface for billions of years. It was a water world, and the story isn't over. While the surface water is gone, there's still a lot of water ice locked away in the polar ice caps and buried underground. NASA's Mars Reconnaissance Orbiter has even spotted what appear to be seasonal flows of briny or salty water trickling down crater walls during the warmer months. There's even tantalizing radar evidence suggesting the possibility of large liquid water lakes buried deep beneath the southern polar ice cap. So, while Venus is a planet that lost its water, Mars is a planet where the water is hiding, just waiting for us to find it. Let's talk about the weather. On any planet, weather is driven by the atmosphere in motion. On Venus, that motion is, well, pretty extreme. The upper atmosphere of Venus is in a state of superrotation, whipping around the planet at speeds up to 360 kilometers per hour, or about 225 miles per hour. That's actually faster than a Category 5 hurricane on Earth. These clouds, made mostly of sulfuric acid droplets, circle the entire planet in just 4 Earth days, which is a phenomenon that still puzzles planetary scientists. Down on the surface, however, the winds are surprisingly calm, just a few miles per hour, because the air is so thick and soupy. Now let's fly over to Mars. The winds on Mars are generally much slower than the super-rotating jets of Venus, but because the Martian atmosphere is so thin, the winds can still kick up a lot of dust. This creates fascinating weather phenomena, like towering dust devils that can be kilometers high, leaving dark tracks across the landscape as they vacuum the surface. These are much larger than their earthly counterparts and have actually been photographed by our rovers, which they occasionally clean the solar panels of. It's a pretty neat and honestly helpful feature of Martian weather. But Mars has a much bigger trick up its sleeve: global dust storms. Every few years, regional dust storms can merge and grow until they engulf the entire planet in a thick reddish haze. These massive storms can last for weeks, blocking out sunlight, causing temperatures to plummet, and posing a serious risk to our solar-powered rovers. We saw this with the Opportunity rover, whose mission ended after a massive 2018 dust storm blocked the sun. So, we have Venus with its incredibly fast high-altitude winds, and Mars with its slower winds that can whip up planet-circling dust storms. Two very different, very dynamic weather systems. A planet's magnetic field is its invisible shield, protecting its atmosphere from being stripped away by the solar wind, a constant stream of charged particles flowing from the sun. Earth has a strong magnetic field, generated by its molten iron core, which is a big reason why we have a thick, life-sustaining atmosphere. Now when we look at Venus and Mars, we find that both planets lack a significant internally generated global magnetic field like Earth's. But how they deal with the solar wind is very different, and it has had profound consequences for their evolution. Venus, despite having no intrinsic magnetic field, creates a borrowed one. As the solar wind slams into Venus's thick upper atmosphere, it creates electrical currents. These currents, in turn, induce a magnetic field that drapes around the planet like a comet's tail. This induced magnetosphere is weak, but it's strong enough to deflect most of the solar wind, providing a surprising amount of protection for its atmosphere. This is a key reason why Venus, despite being closer to the Sun, has managed to hold on to its incredibly dense atmosphere over billions of years. Mars tells a sadder story. Evidence in its crustal rock shows that Mars once had a powerful magnetic field, just like Earth. But for reasons we're still trying to understand, the planet's internal dynamo shut down about 4 billion years ago. Without its magnetic shield, the solar wind was free to slam directly into the Martian upper atmosphere, stripping it away particle by particle over eons. This atmospheric stripping is the primary culprit for why Mars transformed from a warmer, wetter world into the cold, thin-air desert it is today. The loss of its magnetic field was a catastrophic event in the planet's history. So we've compared pressure, temperature, water, weather, and magnetic fields. It all comes down to one big question. Could life exist on these worlds? Let's start with Venus. The surface is completely, utterly inhospitable. With crushing pressure and temperatures hot enough to melt lead, nothing as we know it could survive there. It's one of the most hostile surfaces in the solar system. However, scientists have speculated about a potential niche for life high up in the clouds, about 50 kilometers or 30 miles above the surface. Up there, the temperature and pressure are surprisingly Earth-like. The idea is that microbial life could potentially exist, floating in the sulfuric acid cloud droplets. It's a very speculative and tantalizing idea. The controversial detection of phosphine gas in the Venusian atmosphere in 2020 added fuel to this fire, as phosphine on Earth is primarily produced by biological processes. While subsequent studies have questioned the detection, the possibility of life in the clouds of Venus remains a fascinating if remote hypothesis that drives our desire to send new missions there to sample the atmosphere directly. Now, let's turn to Mars. While its surface is also hostile to life as we know it today, cold, dry, and bombarded with radiation, it is far more promising. The overwhelming evidence for a past warmer, wetter Mars means that the conditions for life to arise may have existed billions of years ago. The key question for astrobiologists is, did life ever get started? And if it did, could it still be hanging on in some protected niche, perhaps as microbes deep underground where there might be liquid water and protection from radiation? This is why Mars is a prime target for exploration. We're not just exploring a planet, we're searching for a second independent genesis of life. So there you have it, a tale of two atmospheres. On one hand we have Venus, a world defined by its thick, crushing carbon dioxide blanket. This creates a runaway greenhouse effect, leading to scorching, uniform temperatures and a surface that is completely hostile to life. It's a cautionary tale of how a planet so similar to Earth in size and mass can end up on such a different and inhospitable evolutionary path. Its past is a mystery, and its potential for life is a long shot, confined to the clouds. On the other hand we have Mars. It's a world that lost its thick atmosphere, leaving it cold, with a thin wisp of air and extreme temperature swings. But its past tells a different story. The evidence is written all over its surface, a story of ancient rivers, lakes, and a climate that might have once supported life. This history, combined with the water ice that still exists today, makes Mars a much more viable and compelling target for exploration. Its thin atmosphere, while a challenge, is also less of a barrier than Venus's crushing, toxic one. Ultimately, understanding these two worlds helps us understand our own. Mars represents a tantalizing possibility of finding past or even present life, making it a key destination for our robotic emissaries and one day, for humans. Venus remains a fascinating puzzle, a vision of a paradise lost. Which of these worlds fascinates you more? Would you like a deeper dive into the theories of life in the clouds of Venus, or would you prefer we explore the latest seismic data from Mars's InSight lander? Let me know in the comments below. Thanks for watching.